Hello dear students, today I will discuss about indeterminate forms. Indeterminate forms is one of the topic of your second unit. Indeterminate form means, so sometimes we are having fractions just like fx upon gx. Two functions, one is in numerator and another is in denominator. Indeterminate form means for a particular value of x, suppose x equals to a, fx is 0 and also gx is 0 for a particular value of x. Then we get like 0 by 0 form. Okay. This is indeterminate form. Okay, but its value, approximate to some limit. That is, maybe its value may be approximate for this point. Separately, this is 0 for this point, but after solving this, we can approximate this fraction of this quotient to a definite value. That is, they are evaluating the indeterminate form. This is indeterminate form for x equal to a. This is either of the form 0 by 0 form. That is indeterminate form. There are another indeterminate form also. Okay. So in this case, just we have to apply a special rule that is called L'Hospital rule. By using L'Hospital rule, we can evaluate this indeterminate form. Okay, so just I will discuss about L'Hospital rule. How can we evaluate this indeterminate form? Whenever for any value of x, the form is like just 0 by 0. Another form is also there, infinity by infinity, 0 into infinity, and 0 power 0, infinity power 0, 1 power infinity. All are indeterminate form. Two functions are there, suppose fx power z, fx into gx, fx power gx, fx power gx, fx power gx. And for a particular value, just we are getting this type of format. That is what? Indeterminate form. Okay, all these indeterminate form can be converted 0 by 0 form. And we can use L'Hospital rule for evaluating the value of indeterminate form. So very simple topic, only we have to find the limit. That is, we have to approximate the fraction to a definite value. Okay, so just Taylor's expansion may be used, or Cauchy mean value theorem may be used for that. So here L'Hospital rule, the statement L'Hospital rule statement L'Hospital rule. What is the statement of L'Hospital rule? Okay, if two function fx and gx, if fx and gx be continuous in interval, suppose CD, containing the point x equals to a. Means our two function fx and gx are continuous in the interval CD, and CD contains x equals to a, containing the point x equals to a, and fa equals to 0, ga equals to 0. At this point, fa equal to 0, ga equal to 0. Okay. fa equals to 0 and ga equals to 0. After that, and also f dash x, g dash x exists. F dash x, g dash x exist at or in interval CD. In this interval, derivative of these two functions exist. Separately. Accept at then limit x tending to a fx by gx equals to limit x tending to a f dash x upon g dash x, provided limit exists. Provided the limit exists on right hand side. Clear? So this is the statement. What is L'Hospital rule? L'Hospital's rule. L'Hospital's rules. Okay, that is fraction fx by gx. At this point, fx and gx are defined in the interval CD, continuous, and also derivative exists in that interval. And then fx by gx what? At a 0 by 0. So this is indeterminate form. For we can approximate this value as a limiting value. So limit x tending to a fx by gx is given by this. Its derivative exists. Possibly at x equal to a means maybe x equal to here f dash g dash exists in this. Also you have to write here g dash x is not equals to 0 in CD, except possibly at x equals to a. That means maybe at x equal to a, g dash x equals to 0. G dash x equal to not 0 in CD, except possibly at x equal to, maybe x equal to at x equal to a, g dash equal to 0. Then further we can apply this theorem. Okay, so here both exist. So this limit is equals to the limiting value of f dash by 0. That means we have to differentiate numerator and denominator separately. Okay, dash dash. And if this limit exists, then we can say that this fraction is approximated to that finite value. That is limiting value of this exists. If g dash x equal to 0, suppose, and f dash x equal to 0 or may not be 0, then also we can use this rule once again for the function f dash and g dash x. Then we can get further double derivative, triple derivative, and up to can get the nth time formula. So we have to differentiate as many times as we would require to find a determinate form. Okay, here. So just its proof is very simple because it is based on we can find its value as using Taylor's theorem. That means this now limit exists. So f dash x by g dash x, just limit divided to f dash a g dash a. Okay. So this is what L hospital rule. It can be used for evaluating the. See here fx gx both are continuous. So for establishing this relation, this formula, this rule, we can use continuous difference and derivative exists. Then we can use Taylor's theorem, that is general mean value theorem. So proof is very simple. So just we can see that using Taylor's formula or Taylor's theorem, we can say also Taylor's formula. So just use this Taylor formula to evaluate the limit. Okay. So here for proving it, so very simple. Here see, using Taylor's expansion, we get using Taylor expansion, we get just like this: limit x tending to a fx upon gx. Just we have to find the value of this fraction, limiting value. Just here use Taylor's expansion. Just we can write here x tending to a. We know Taylor's expansion about x equals to a. Just use that expansion. X tending to a, numerator and denominator both. Just use this Taylor expansion. Okay. So first, value is what? fa plus x minus a, f dash a, plus x minus a square by 2 factorial f double dash a, and so on. Just we are having this type of expansion of fx, Taylor expansion. Okay. So similar, just for z, ga plus x minus a, f dash, g dash, g dash a plus x minus a square upon 2 factorial g double dash a. Just we can use Taylor expansion formula in place of fx and gx. Just expand the function fx and gx by Taylor expansion. Okay, about the point x equal to a. Now, in the statement, it is given that f equals to 0 and g equals to 0. That is, this is 0, this is 0. So we get the limit x tending to a. Here, this is 0 plus x minus a, and in the remaining term, we can take common x minus a. So we get what? F dash a plus x minus a upon 2 factorial f double dash a plus and so on. Okay. So divided by, here also 0 plus x minus a common and z dash a plus x minus a, not a square here, here is a square, sorry, here not a square, this is right, x minus a upon 2 factorial z double dash a plus, so this is, we can get like this, here this is 0, this is 0, x minus a, just we cancel out because this is not x equal to not a, so x tending to a, so we can cancel out this. So here limit x tending to a we get what? F dash a plus x minus a upon 2 factorial f double dash a. All the higher terms, all the terms after first term, the x minus a, here also x minus a, here also x minus a. So we see that x minus a by 2 factorial g double dash a. So this is equals to what? F dash a upon g dash a. G dash a is not equals to 0. So this is formula. Just we can find like this. That is what? X tending to a fx by gx. If f equal and g equals to 0, that is indeterminate form, then one time differentiation, just differentiate this and put x equals to a. We can get the value like this. Okay, g dash a equal to not 0. So limit x tending to a fx upon gx. So this is L hospital rule. Okay. Now, suppose we get again f dash a and g dash a are 0, then just we can use this rule, just like for the function f a, fx and gx, we apply this rule. Just if f dash a and g dash a equal to 0 both, and we get again indeterminate form, then we can again use this formula in place of f and g, just take f dash g dash. Then just we can proceed further and we can get formula. Okay. That means if f a equals to 0, f dash a equals to also 0, g a equals to 0, z dash a equals to 0, then we can use this, we can use the above rule, we can use the above rule for f dash x and g dash x for x equals to a. Just in case of fx and gx, just use f dash x and g dash x. Then, and we get limit x tending to a fx upon gx is equals to what? F double dash a upon g double dash a. Here g double dash a is not equals to 0. Similarly, repeating this process up to n times, we can get what? Limit x tending to a fx by gx equals to limit x tending to a nth derivative a upon nth derivative a. Okay. So this is L hospital rule. Just here, what is meaning? N times means what? Just f is 0, f dash is 0, f double dash is 0, and up to f n minus 1 derivative is 0. Then we can get up to n derivative. Just we have to differentiate numerator and denominator as many times as we would require to get determinate form. Determinate form means just we can find the limit and we can get a definite value. Just differentiate as many times as we require for getting determinate form. Okay. So just using this rule, we have to solve some questions. Just all the questions are for evaluating the indeterminate form. Okay. So here indeterminate form are of other form also here, just 0 by 0, infinity by infinity. That means just we can see here that if we are getting indeterminate form, first of all, just we'll use, suppose we are getting like this form, 0 by 0. That is fx by gx tending to this format as x tending to, that means what? Fx tending to 0 and gx tending to 0. That is 0 by 0 format. Okay. So if we get for x tending to, just like x tending to a particular value, x tending to a, as x tending to a, as x tending to a, like this, then this is indeterminate form. And if x as x tending to a, fx tending to 0, okay, and both tending to infinite, then what will be the format? Infinity by, then fx by gx tending to what? Infinitive upon infinitive form. So it can be written also 0 by 0 form. How? Just like this. Fx by zx, f by z tending to 1 by z upon 1 by f. We can write. This can be written 1 by z, 1 by f. So here z tending to infinite, f tending to infinite means this is tending to 0 by 0. So it can be written also, infinity by infinity can be written in terms of 0 by 0. That is for written f by z, fx by zx tending to 1 by z by 1 by f. Just we can write like this. Tending value, limiting value. Okay, here limit x tending to a. Just we can use this for getting 0 by 0 format. So this can be converted to also this format. Here, this is the 0. Whenever we get the infinity by infinity form, just our target is what? For this form also we can apply L'Hospital rule. So just direct you can differentiate it, numerator and denominator separately. Okay, separately differentiate, not as a quotient rule, u by v format. That is not applicable here. Just separately you have to differentiate. Clear? By taking it in this form, also you can differentiate. But whenever we get infinity by infinity format, just you can differentiate direct and get a determinate value. But basically, just we convert this form to 0 by 0 form and then use L'Hospital rule. Because in that case, question can be solved very easily. Otherwise, just if you have to differentiate directly of this format, then differentiation may be tedious in the further step. Okay. So just convert first in 0 by 0 format and then use L'Hospital. Okay. These two format are indeterminate format, and also there are another format just like this is one of the format, this is a format, and also infinity minus infinity, this is also a format. That is, suppose fx minus gx. Okay, this tending to infinity minus infinity. That means what? Fx tending to infinity, gx tending to infinity, as x tending to a, or x tending to maybe infinity, maybe minus infinity, or maybe x tending to infinity, x tending to minus infinity, just fx tending to infinity, gx tending to infinity. This is the infinity. This is also indeterminate form. Just it can be converted to 0 by 0 format. Just taking its, combine this two as taking LCM, or you can write it f minus z is equals to 1 upon z minus 1 upon f upon 1 upon fz. Just you can see solving this, you can get f minus g. This because here f tending to infinity, g tending to infinity, this tending to infinity, this tending to infinity, 0 minus 0, 0 by both tending to infinity, 0. So this is 0 tending to 0. 0 by 0 format. You can convert it. Okay, so this can be also converted. If fx minus gx, just taking LCM just like this, and you can solve it. Okay, by converting 0 by 0 format and then applying L'Hospital rule. And another form is what? Like 0 to 0, power 0, infinity power 0, and 1 power infinity. All are indeterminate form. Okay, all are indeterminate form. So here 0 power 0 means what? So just we see that here power involving. Okay, power involving, that means we can take logarithmic. Just suppose fx power gx. fx power gx, and as x tending to a, this tending to 0 to power 0. That means what? F tending to 0 and g tending to 0. Here, this is fx, this is gx. fx, gx. fx tending to 0, gx tending to also 0. Okay? So, this format can also be solved by using logarithmic. Just like this, fx power gx, like this. Just suppose this. Here just what? Limit. This is format. Now we can take logarithmic on both sides. So log y equals to, and x tending to a, logarithmic of fx just we can write this logarithmic. Logarithmic of y equals to, just log, go to the inside, the limit of log of this. Just you can convert it as what? Limit x tending to a gx, because power come to the front of log and log of fx. So this tending to, in which format? Because gx tending to 0 and fx tending to 0, log 0 infinity. So this tending to was which format? 0 to infinity. 0 into infinity. The 0 into infinity is also another format. Okay. 0 into infinity. 0 into infinity can also be converted like this. 0 into infinity means fx into gx. These are two functions. Okay. So, as x tending to a or x tending to infinity, x tending to minus infinity, just this tending to, if 0, that means what? F tending to 0, g tending to infinity. F tending to 0, g tending to infinity. So it can be converted 0 by 0 format. How? Because here 0 into infinity, that is fx, this is gx. So infinity, we can write it f by 1 by z. F by 1 by z. Because z tending to infinity, z tending to infinity, so this is tending to 0 or f tending to 0, so 0 by 0 format. So fx into gx, 0 into infinity, so this can be converted as what? Fx into 1 upon divided by 1 upon gx. So f fg can be written f upon 1 upon g. So this is tending to infinity, this is 0, this is 0. So 0 by 0 format can be changed, this format, and this comes to the 0 to infinity. So it can be converted 0 to 0 format, and we can solve by using a hospital rule. Similarly, here, this logic may be used for here also, okay. And for solving or evaluating indeterminate form, we can also use the special series expansion, just like e to the power x, sin x, cos x, tan x. Okay, so series expansion can be also used for that. Okay, so just now we will solve some questions for evaluating the indeterminate form. Okay, here taking first question, just take question first. evaluate solution evaluate limit x tending to pi by 4 sec square x minus 2 tan x sec square x minus 2 tan x upon 1 plus cos 4x 1 plus cos 4x. Okay, so just this is the limit and we have to find this value indeterminate form, because just put x equals to pi by 4 here. Cos pi by 4 means what? 1 by root 2. So sec means root 2. Root 2 square 2. So this is 2. And 10 pi by 4 1. 2 minus 2 0. So numerator tending to 0 and denominator cos 4 into pi by 4. 4 4 cancel. Cos pi minus 1. So this is also 0. So 0 by 0 format. It is 0 by 0 form as cos 4 pi by 4 is equals to cos pi equals to minus 1 and sec square x means pi by 4 equals to 2. Okay, 0 by 0 form. So applying L'Hospital rule. So x tending to pi by 4 under limit, just we have to differentiate denominator and numerator. So here numerator, just differentiate it. What? Sec square x minus 2 tan x what? Dash upon 1 plus cos 4x dash. We can use differentiate it. Applying L'Hospital's rule. Clear? Now, limit x tending to pi by 4. Just differentiate it. Differentiate total. So, first this x sec square 2 sec x into sec x. Differentiation of sec x tan x. Sec x tan x minus 2 sec square x. Okay? Minus 2 tan square x upon here differentiation 1 0 plus 4 sin 4x minus, just we get after differentiation, just differentiate it this. So just write under limit x tending to pi by 4 here. What we get? Sec square common, 2 sec square common, 2 sec square common, tan x minus 1 upon minus 4 sin 4x. Now just see, x tending to pi by 4, sin pi 0. Sec square pi by 4 means again what? 2. 4 sec square 2. Tan x minus 1, x tending to pi by 4, tan pi by 4 1. 1 minus 1 0. This is 0. Again 0 by 0 format. Again 0 by 0 form. Again 0 by 0 form. So again apply L'Hospital rule. Just we can apply L'Hospital rule up to that desired step for getting determinate form. So 0 by 0 form, just we can again apply L'Hospital rule. Apply L'Hospital rule. Okay, that means differentiate it. Okay, so here 2 just we can cancel out here 2, so 2 can be cancelled out, so just here minus 2 sin 4x. Okay, so just first function, second function. This is first function, this is second function. Differentiate. So first function means differentiation means 2 sec square x. Just this 2 is cancelled out by this 2. So here 2 we will use in the denominator. Okay. 2 sec square, this differentiation of this 2 sec square x into sec x. Second function, 10x minus 1. Okay, and second term, this will as it is at, and differentiation of this 10x minus 1 0, 10x sec square x minus sec square x into sec x. Okay, upon here 2, so minus 2 sin 4x differentiation into 4 sin cos 4x. So we will get like this. So here we can see that cos pi, what? X tending to pi by 4, cos 4 into pi by 4, cos pi minus 1. So this is minus 1, minus plus 8. Just denominator will plus 8. And here cos pi by 4, this is 2. This will be 0. Because 10 pi by 4 minus 1, this is 0, and pi by 4, so this is what? Sec square means 2 sec root. Okay, so just we can get the limit as apply limit 2 into sec square means what? Here 2 root 2 1 minus 1 minus 2 into root 2 upon here just 8 equals to what is the limit of this? Sorry, this is not square. 2 sec x into sec x tan x. Here, this differentiation is wrong here. 2 sec x into sec x tan x into sec x tan x. Sorry. 2 sec x, differentiation of sec x square x, 2 sec x tan x and as it is this function. Okay, so here root 2, root 2, 2. The root 2, 1. So we can write like this, root 2, 1, this. Here sec square x and sec x. Sec square x, sorry, sec square x. Just differentiation of 10x is sec square x. Just remember the derivative and just carefully differentiate it. Okay. One time if you get some mistake, then answer will be wrong. So just take care for differentiation. Okay. So sec square and here sec square. Sec power 4. That is sec square means what? 2 into 2. By this, just we can use now limit. What? This is 0. 1 minus 1. This is total 0. 2 into 2, 4. By 8, 1 by 2. So here limit is 1 by 2 also, because ten x minus 1, 10 square sec square x, here minus sign is here. So this is plus sign is there, no? So this is equals to 1 by 2. So this is limit. Okay. So this is the value. So here plus sign is there, no? Because not quotient formula is here. Here formula for only product rule. This into this, just here plus sign. Sec square into sec square. Okay. So 1 by 2 is the limit. This is the value of this indeterminate form. Okay. So here what is the rule? Just you have to differentiate separately numerator and denominator. Separately, not by using quotient rule. So this 0 by 0 form. So we can use L-Hospital rule, that is differentiate both numerator and denominator separately. This differentiation is this differentiation is this. Now, just taking common out and again we see that this is 0 by 0 form. So again apply L-Hospital rule. Just differentiate numerator and denominator. Here 2 divided by 2, this here just use 2. And then again differentiate and put the value, just we can get finite value. This is the value of this indeterminate form. Okay. So just we will use this rule 1 by 1. Okay. Take second question, because different type of questions you can get. Okay. So here, see, second question. Just I will solve 1 by 1 some questions to get idea how can we find the value of indeterminate form. So here, different type of questions may you get. Okay, so take second question, that is x to the power x minus x limit x tending to 1, x to the power x minus x upon x minus 1 minus log x minus 1 minus log of x. Just we have to determine the value of this. What is the value of this limit? Okay. So this is also indeterminate form. You can see x tending to 1. Here 1 power 1 1 minus 1 0. Here 1 minus 1 0 minus log 1 0. So it is of 0 by 0 form. It is of 0 by 0 form. So apply an hospital rule. Limit x tending to 1, x to the power x minus x dash upon x minus 1 minus log x dash using L hospital rule. Using L hospital rules. Just differentiate. So now solve it. Okay. Here. Let y equals to x to the power x implies log y equals to what? X log x. And you know how can you differentiate it? Simple. Okay. 1 by y dy by dx equals to here with respect to x. So x 1 log x minus x into 1 by x. So here we see that dy by dx is equals to what? Y into log x minus 1. That is what? Derivative of x to the power x. Y means x to the power x is equals to what? Y. X to the power x log x minus 1. Log x minus 1. So this is the derivative. Okay. Sorry, this is plus sign. Okay. So x to the power x 1 plus log x. Its derivative. So just write here x to the power x 1 plus log x minus 1. Just differentiate it. Total differentiation means just differentiate this numerator. And similarly here differentiation. X 1 minus 0 minus 1 by x. Just we get like this. Now x tending to 1. So 1 minus 1 0. X power x. X power x. 1. Log 1 0. So 1 into 1 1 minus 1 0 by 0 format again. Again 0 by 0 format. Again 0 by 0 form. Again 0 by 0 form. So just once again apply L hospital rule. So here again L hospital rule applied. Rule is applied. Okay, again L hospital rule applied. So here just differentiate it, numerator and denominator. Okay, this is first function, this is second function. So first function as it is, second function derivative 1 plus 1 by, not 0 plus, because 1 0 log x 1 by x. This is first function, second derivative, and derivative of first function, its derivative x to the power x 1 plus log x. 1 plus log x. 1 plus log x. Its derivative into 1 plus log x. Into 1 plus log x. And minus 1 is minus 0. You can write. Not power, just here. Again apply this minus 0. Just differentiate numerator. And also denominator 1, 0 minus 1 by x square plus 1 by x differentiation minus 1 by x square minus plus. Just now we can see what is the result here. Limit x tending to 1, just use x to the power x, 1 by x, so x to the power x minus 1 plus here x to the power x, 1 plus log x square upon 1 upon. Now we can find out the value because x tending to 1 here, 1 by 1 square 1. Here x to the power x minus 1, x to the power 1 to the power 1 minus 1, 0. 1 to the power 0. What? 1. 1 plus 1, 1. 2. Limit will be 2. So this is 2. Answer. Okay. So value is 2. So this is the value of this indeterminate form. Approximate value. Just use L'Hospital rule. Okay. So this type of evaluation is important for solving questions. Now take another question. This question third is, determine the values of ABC so that the limit of this is tending to 2 as x tending to 0. So here we have to find the value of ABC. Here constants are given in the fraction ABC. Just we have to find the ABC provided its limit is 2 as x tending to 0. So according to L'Hospital rule, just we know either limit exists or the fraction is of the form 0 by 0. So here just third question, we have to find the values of A, B and C so that limit x tending to 0, because x tending to 0 is given, na? X tending to 0, a to the power x minus b cos x, a e to the power x minus b cos x, a e to the power x minus b cos x plus c to the power minus x plus c e to the power minus x upon x sin x, x sin x is equals to 2. We have to find the value of ABC. That its limit is 2 as x tending to 0. As x tending to 0. Just okay. So on the basis of this condition, its limit is 2. Just we have to find the value of ABC. Okay. So here three constants are given. Three constants are given. Just that is we have to find these three constants. So three relation we will require for finding these values. So here one condition is this limit is this 2, and remaining two conditions what will be the condition. Just see, since we see that limit x tending to 0, this fraction, that is a e to the power x minus b cos x plus c e to the power minus x upon x sin x. This limit is since we see that in the given limit, since we see that in the given limit this the denominator is 0 for x equals 0, because x equals 0, sin 0 0. Here its value will depend on the value of ABC. Value of numerator will depend on value of ABC. Since its denominator is 0 and its value is depend on ABC, so for existing this limit, numerator must be equal to 0 for x equal to 0 for 0 by 0 form, and then we can proceed for finding the value of this limit according to L'Hospital rule. So for existing of this limit, okay, just we can write what? The denominator is 0 for x equal to 0. So this denominator just you can write here for x equals to 0. So for existing this limit, the fraction the numerator should be equal to 0 for x equals to 0, because its limit, if its limit exists, then if this is 0, then this should also be 0, and then we can proceed according to L'Hospital rule. So denominator is 0 for x equal to 0, so for existing this limit, the numerator should be equals to 0, because limit is exist too. So there the numerator should be equals to 0 for x equals to 0. That is that is that is in numerator just put x equal to 0. A e to the power 0 minus b cos 0 plus c e to the power minus 0 equals to 0. So implies what? A into 1 minus b into 1 plus c into 1 equals to 0. So this is equation first. This is equation first, suppose. Now on considering numerator is 0, using L'Hospital rule. We get limit x tending to limit x a e to the power x on considering this. Just differentiate it. L'Hospital rule use means differentiate it and differentiate it in this limit. So a e to the power x, then e to the power x, cos derivative of cos minus sine, so plus b sine x and minus c e to the power minus x. This is differentiation of numerator upon differentiation of denominator. X 1 into sine x plus x cos x. This. Okay. Here also we see that x tending to 0, 0, 0, denominator 0. Here we also see that here we see that denominator is 0 for x equals to 0. So, for existing this limit numerator should be equals to 0 for x equals to 0. Therefore, also just numerator put x equal to 0. So a e to the power 0 plus b sine 0 plus minus c e to the power minus 0 equals to 0. So implies a minus c equals to 0. This is equation 2. A minus c equals to 0. This is equation 2. Because this is 0, this should be, this value of this should, is depending on the value of ABC. So this should be also 0 for existing 0 by 0 format. Okay. Similarly, repeat this. Now we can write after this line just on considering numerator is 0 using L'Hospital rule, we get in this, considering numerator, in this considering numerator as 0, that is 0 by 0 format. So L'Hospital rule, using L'Hospital rule we get what? Differentiate it. Limit x tending to 0, differentiate it. A e to the power x plus b cos x minus c e to the power minus x upon, again differentiate it. Clear? Here sin x cos x, product of two function, so plus x into minus sin x. Just taking first function and there's differentiation of this minus, and then x 1, so 1 into cos x. Just we have to differentiate numerator and denominator by L'Hospital in this, considering this is 0. Now so this equals to, this implies, we can write here, just here we can see that x tending to 0, this is 1, this is 1, this is 0, so 2. So numerator is not, denominator is not 0. So limit x tending to 0, a e to the power x plus b cos x minus c e to the power minus x upon two cos x minus x sin x is equals to 2. It is given. Its limit is given because denominator is not 0 now. So we can write this is equals to 2. Now solve it. Okay. So this, just put the value a e to the power 0 plus b cos 0 minus c e to the power minus 0 upon here 2 cos 0 minus 0 into sin 0 equals to 2. Now solving it, we can get a relation also. Here what? A plus b minus c, a plus b minus c by 2, here 2 equals to 2. So this implies a plus b minus c equals to 4. So this is equation 3rd. Now using 1, 2 and 3 we can get the value of a, b, c. Okay. So just solve it and find the value of a, b, c. Okay. Now solving 1, 2 and 3, we can get a equals b equals c equals, just solve it. Okay. from this relation, just we see that what A equals to C here. Just put A equals to C here. A equals C. A equals C. C cancel. B equals to 4. So just we see that B equals to. I think just this is not B plus C is 0. Okay. In the previous part, there is. So here plus sign is there in the previous part because just two time differentiation of this now. First time differentiation minus and second time differentiation plus. So here plus will be there. Okay, here plus will be there. Just correct it in the previous part. Just here plus sign because two time differentiation na. So there was mistake some what minus because one time differentiation minus and again differentiation plus. So what first differentiation and second time differentiation minus and then again minus to plus. So a plus b plus c equals to 4. Okay. So a equals to c put here. So what a equals to c, that is b plus 2c equals to 4, and just we get like this. Okay, from here a equals to c, from here a equals to c put here. So a equals to c means b plus 2c equals to 4. Also from here just put a equals to c, a equals to c there. So what will be minus b plus 2c equals to 0. So here just adding 4c equals to 4, c equals to 1, so c equals to 1. And c equals to 1, so a equals to 1. And b equals to what? C and a 1, 1, 1, 1, 1, b equals to 2. So a equals to 1, b equals to 2, c equals to 1. So 1 to 1. 1 to 1. Okay. So solving this, just here plus sign because in the previous question just at the time of differentiation just we are omitting the sign. So two time differentiation just we know. Okay, first time differentiate minus sign and second time differentiate plus sign. So plus sign should be there. Plus c. Okay. So just solving 1, 2, 3 we can get a equal to 1, b equal to 2, c equal to 1. 1 to 1. Okay. So this is the technique for finding the constants from the given condition that limit exists. So for if denominator is 0, then just you can consider the right hand numerator is also 0 for x equal to 0, then you can get the equation, and by solving that equation finally you can get the value of constant. A equals to 1, b equals to 2, c equals to 1 is here. Okay, so now just like this one by one here we have to solve some questions just like infinity by infinity, 0 to power 0. Okay. Now take another question, that is just we can also use series expansion of elementary functions as a Maclaurin series expansion, Taylor expansion, any type of expression can be used for solving also indeterminate form. So to take these questions, just find limit x tending to 0. Here limit x tending to 0, 1 plus x or 1 by x minus x. Okay, 1 plus x or 1 by x minus e by x minus e by x. Just we have to find this indeterminate form. Here x tending to 0, that this is e minus e 0 by 0, 0 by 0 form. This is 0 by 0. Okay. So for solving this, we can use series expansion also. Okay. So here, just this is power quantity. We know that any type of formula just you can use for solving this fraction to give a determinate form. Just like this, we know that a equals to e to the power log a. This is a formula we know. Log base e. Okay. This. Here 1 plus x or 1 by x can be written as what? This is equals to e to the power log of 1 plus x to the power 1 by x. Just we can write like this. Because something equals to e to the power log of something. This. Clear? So here we can write this is equals to this quantity is equals to this is equals to e to the power 1 by x log of 1 plus x. And here e to the power 1 by x into log 1 plus x series can be used. Since log 1 plus x is equals to what? X minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. Okay, we know. So just use this expression here. What? X minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. Just this is equals to, we can write e to the power 1 minus, just multiply 1 by x to the inner side. So x minus x by 2 plus x square by 3 minus x cube by 4 plus and so on. This can be written as e to the power 1 into e to the power minus x by 2 plus x square by 3 minus x cube by 4 plus and so on. So now exponential expression e to the power x. E to the power x. Since this is equals to 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. Also we know that this. So just use this result for this. E to the power this total single quantity. So this is equals to what? E into e to the power of this. So we can write like this. What? 1 plus x plus 1 by 2 factorial x square plus and so on. Just we can write like this. In this plus this total quantity minus x by 2 plus x cube by 3 minus x power 4 by 4 and so on. Here same thing is there. Minus x by 2 plus x cube by 3 minus and so on. This. Clear? So here we can write this is equals to E multiplied E and here minus EX by 2 plus EX cube by 3 minus EX4 by 4 plus just write 2 3 terms only here. You can see just like E, okay, then what, my x, because x square, then we will get a square term greater than x. Here only single x, so minus ex by 2. Now second term x cube, or here x square term is also, so x square, whenever the square it, the x square by 2 square and multiplied by 1 by 2 factorial, so 8. So we can write what, e x square 11 by, here also just see x square is here, x x square x cube, x square x cube, here x square is this, like this term, because square cube, x square cube, x square cube, x square cube, like this. Now minus x by 2 is there, x square by 3, e into x square by 3. Here just after squaring this term, just x square by 4 by 8. So x square by 8 plus here x square by 3 plus x square by 3. So 24. So here 3 plus 8, 11 by 24 x square. So we can write plus 11 by 24 e x square, and second term, and then next term will be x square and x cube and so on. In each term just you will get what, power of x, just like this. So this is the value of this. This can be written as like this. So now use this value. So this is what, 1 plus x to the power 1 by x. Now this value we will use here for finding this indeterminate form. In which form? This 0 by 0 form. This is 0 by 0 form. So for solving this, just we use series expression, not for, just not use direct L'Hospital rule, but use series method. Series expansion are used here, log 1 plus x into the power x, just this. Okay, now use this value here. So series can be also used to determine indeterminate form. So here this is equals to limit x tending to 0. In place of this, just use this, e minus ex by 2 plus 11 by 24 ex square plus and so on, this minus e, this by x. Okay, using this, just you can write using 1. Okay, now see, we see that e cancel and 1x also will be cancelled from numerator and denominator by taking common. Okay, so just after this step we can get the value of this limit very simply. Why? Because just here, how e and this e will be cancelled out, x and each term will contain x. So here limit x tending to 0, e cancel, x common, then we get minus e by 2 plus 11 by 24 x Ex plus and so on upon x. Okay, so this x will be cancelled. So here limit x tending to 0 minus e by 2 plus 11 by 24 x e plus and so on. Here after putting x tending to 0, 0, 0, 0, 0 and so on. So this is equals to minus e by 2. So this is our answer. Okay. So here just we use what? Series expansion. Log 1 plus x e to the power x, etc. So series expansion can be also used for finding the value of indeterminate form. So here now we discuss about infinitive by infinitive form. Just we know infinitive upon infinitive form can be reduced to form 0 by 0 form. Just one to step you can just L hospital rule can be used for also infinity by infinity form. But successively differentiation will be difficult. So here just we will try to reduce it in 0 by 0 form. So here take question 5. So limit just what? X tending to 0 log sin 2x by sin x. X tending to 0 log sin 2x by log sin x. Log 0 tending to infinity. Okay. So here what? X tending to 0, sin 2x means 0, 0. Log 0 by log 0. Infinity by infinity form. So which form? Infinitive upon infinitive form. Just we can use direct L hospital rule in this form. But for easy calculation, just we convert this form to 0 by 0 form. Just writing 1 by this, 1 by this, and then 0 by 0 form can be written. So first of all, direct apply L hospital rule. L hospital rule. Okay, here. So what we can write? Just differentiation. Just differentiate numerator. Log sin 2x. That means 1 by sin 2x into differentiation of sin 2x. 2 cos 2x upon here 1 by sin x cos x. Just we get what? Limit x tending to 0 to cot 2x upon cot x. 10 0 0 10 0 0 cot 0 infinity. So this is again infinity by infinity form. Again infinity by infinity form. Okay. So just we can retain, we know just differentiation will be complicated if we take always infinity by infinity form. So just we can convert it as 0 by 0 form. X tending to 0, just 1 by cot. So 1 upon 1 by cot, that is 10 to 10x upon 10 to x. You can write. Okay. So this is what form? 0 by 0 form. We can write. Now here, limit x tending to 0, 10x by x and 2x by 10x. We can write like this: x multiplied numerator denominator, 2 is here. So if we write like this, then limit of this and limit of this as x tending to 0, 1. So this is equals to 1 into 1 equals to 1. Limit x tending to 0, this is 1. Limit x tending to 0, this is also 1. So value is 1. Okay. So this is the value of indeterminate form. First of all, it is from infinity by infinity form. Just apply the L'Hospital rule, and then we see that this is also infinity by infinity form. Just convert it in 0 by 0 format, 1 by fx, 1 by gx by doing that. Now 10x, 10x, so we can adjust like this, that is 1. Okay, so here one more question, just in infinity by infinity form, just you can see like this. X by root 1 plus x square. Okay, question 6. So just our target is what? Finding the value of limit, that is approximate value of indeterminate form. Okay, so just find limit. Here what? Question 6. Just question 6 is what? X by root 1 plus x square and x tending to infinitive. X tending to infinitive. Limit x tending to infinitive x upon root over 1 plus x square. Okay, just we have to find this. Here x tending to infinitive, this is infinitive, total infinitive, infinitive, infinity by infinity form. Infinity by infinity form. Just apply all L'Hospital rule direct. Here we can get what? X tending to infinity. Here maybe x tending to infinity, x tending to minus infinity, plus infinity, x tending to a, 0, 1, 2, etc. So using L'Hospital rule. L'Hospital's rule. Okay. So L'Hospital rules, that is differentiate 1 upon. This differentiation is what? 1. This differentiation minus 1 upon 1 plus x square root. Root x minus 1 upon 2 root x. Minus 1 upon 2 root x. Okay. So this is what? Minus differentiation of root x is what? 1 by 2 root x. 1 by 2 root x square, and also differentiation of what? 2x. Okay. So this is what? Which format? It can be also written as x to the power root over 1 plus x square upon x, limit x tending to infinity. Infinity by infinity form again. Okay, infinity by infinity form. Because x tending to infinity, this is infinity, this is infinity. So just again differentiate it. Again differentiate it. So we can differentiate it. Limit x tending to infinity again use L hospital rule. L hospital rule. Okay, again L hospital rule. So we get here 1. Differentiation of x is 1. Its differentiation 1 by 2, 1 upon root of 1 plus x square into 2x, 2 to cancel x by. So it can be written as limit x tending to infinity. So x upon root over 1 plus x square. Just we get this form again. So what we have to do now? Just take here or a substitution like this. Just we get now what? This same thing as given in the question. So in this case, to determine it, let us put z equal to 1 by x square. Then z tending to 0 as x tending to infinity. As x tending to infinity. Now it can be solved. Therefore, then we get limit x tending to infinity, this x upon root 1 plus x square. What can be done here? Just take, for getting 1 upon x square, just take common x square from root sign. So you are left limit x tending to infinity x upon just x, take common x square from root. So 1 by x square plus 1. Outside root it will be x. So x cancel. Here limit x tending to infinity 1 upon root over 1 by x square plus 1 implies limit z tending to 0 1 upon root over z plus 1. Just we can see, because this is x tending to infinity implies z tending to 0. So z tending to 0, here z. So z 0 root 1 1 1 by 1 equals to what? Limit 1. So this is the determination of this limit. Here we use this substitution. So by using this type of substitution, you can also get the value. Okay. Now take question 7. Here just take question 7 for calculating next limit. Here limit x tending to 0 log of 10x log 10x 10 to x. Okay, log 10x 10 to x 10x x tending to 0. So this is also of form what? Log 10x to the base 10x. So we know here formula that log of a to the base b. Here log a to the base b is equals to what? We know base can be changed log okay like this. So this is equals to what? First of all write limit x tending to 0 log of 10 to x. Base is writing nothing, but that means e upon log of 10x. Here x tending to 0, that is this is 0, this is 0, log 0 by 0, log 0. This is infinity by infinity form. Infinity by infinity form. So just use L'Hospital. Okay, just use what? L'Hospital rule. X tending to 0, differentiate it, use L'Hospital rules. L'Hospital's rule. Okay, so just differentiate 1 upon 10 2x into 2 sec square 2x upon here also 1 by 10x sec square x. So from here we can see that sec square to x sin by cos, one cos can cancel, cos to a cot 2x by cot x, cot 2x by what? Cot x. Okay, just see sec square we can set up here just see x tending to 0 1 1 1 by 0 infinity 1 by 0 infinity by infinity form again. Here limit x tending to 0 just infinity by infinity form. So just set up it 10x sin by cos. So we can write like this sin x into, because just see here sin by cos, so cos here cos 1 sec cancel, cos by sec, so here we can take it to numerator. So what? Sin x and 1 sec go to numerator cos x, and this 2 is here upon here, just denominator here sin 2x by cos 2x, and this go to the denominator as cos square x. So 1 cos 2x, 1 cos will be cancelled. So here what? Sin 2x into cos 2x we can write like this. So now we see that 0 by 0 form. What form? 0 by 0 form. 0 by 0 form. Clear? Because this is 1, this is 1, this is 0, this is 0, 0 by 0 form. Now, here we can see that just like 2 sin x cos x, sin 2x upon here sin 2x cos 2x, sin 4x, 2 into 1 by 2, so 1 by 2, just like this. Okay. Now, we can adjust like this. Limit x tending to 0, 1 by 2 is here. So, just we can write what? 2. Also, it can be set up like this. Sin 2x by 2x into 4x by sin 4x, where x cancel, x cancel, 2 go to the numerator. So this type of setting can be done, and x tending to 0, this is 1, this is 1, so equals to 1 into 1 equals to 1 is limit. Okay, 1 is limit. So this is the value of this limit. Clear? So just try to find the fraction in a determinate form and then apply known formula. Okay, so this is also infinity by infinity form. Now just take questions as 0 into infinity form. The another form is, we know what? 0 into infinity form. So if the format is given as 0 into infinity form, then we can solve it by also doing it in the form of 0 by 0 form. Here take question a minus x pi x by 2a 10. Limit x tending to a. Just we have to find its value. Limit x tending to a minus x and 10 of pi x upon 2a. Clear? This is. So how can we write it? What? In this format? What is the format? 0 into infinity form. 0 into infinity form. So it can be written as a, in which form? Either infinity by infinity form or 0 by 0 form. So generally, just in this type of questions, we are writing first infinity by infinity form and then reduce it in 0 by 0 form. So here, this tending to a means this is 0. So infinity by infinity form, how can we create it? Like this, x tending to a 10 pi x by 2a upon 1 upon a minus x. This is tending to 0, so 1 by 0 infinity, this is also infinity. A cancel, 10 pi by 2, 90. So very simple. This is what form? Infinity by infinity form. Okay, apply what? A hospital rule. L hospital rule. Okay, just calculate this limit. What? Infinity by infinity form. So apply L-Hospital rule. X tending to what? A. Just differentiate it. 10 means sec square pi x by 2a into pi by 2a, pi by 2a, and differentiation of this 1 upon x minus 1 upon a minus x square into minus 1 minus x. So this is value. Now here we see that in which form is this? In this, just in which form is this? This is also x tending to a infinitive, here infinitive, because x tending to a sec pi by 2. Cos 90 is what? Cos 90 is 0. Sec means 1 by. These are again infinity by infinity form. Okay, again infinity by infinity form. So apply infinity upon infinity form. So just again differentiate it. It is also infinity by infinity form also. After applying infinity by infinity form, so we can convert it infinity by infinity form, then infinity by infinity form. Now for differentiating, just rewrite it in 0 by 0 form. So limit x tending to a, for 0 by 0 form, just we invert it. This go to the minus plus a minus x square upon here. Just we see that pi by 2a is constant value, okay, upon 1 upon 1 by sec square, that is cos square. Cos square pi x by 2a, cos square pi x by 2a, okay, cos square pi x by 2a. This is what, in which form? Just x tending to a, by a cancel, cos 90 means 0, this is 0, this is also x tending to a, this is 0. So 0 by 0 form. So 0 by 0 form. Now differentiate. Again, use L'Hospital rule. Okay, so use L'Hospital rule. L'Hospital rule. L'Hospital rule. So what? Here, just limit x tending to a, pi by 2a, constant value. Just differentiate cos square. What? Cos square means, and here a minus x square, that is what? 2a minus x into minus 1. 2a minus x into minus 1. Pi by 2 constant term. This cos square, differentiation 2 cos pi x by 2a into cos means minus sign pi x by 2a, and also pi by 2a, pi by 2a. So pi by 2a cancel, 2 cancel, this is minus, so x minus a by this. Okay, so we get x tending to a, this is also 0, and here x tending to a cos 90 is 0, again 0 by 0 form. So again differentiating. Okay, it is also 0 by 0 form. This is equals to this. Again use L hospital rule. Here, just this cancel, here 2 cancel, just a minus x means x minus a, just differentiate it. X tending to a minus x minus. So, minus 1 into minus 1 upon 2 to cancel, this cancel. So, here, just first minus sign is there. So, minus of this into this. So, cos and sine both are there. So, differentiate it. The first function is this, minus sign taking outside. Now, differentiate it. Cos 2x, this. So, cos means minus sign pi x by 2a into pi by 2a. And also minus sign is there. So, sin pi x by 2a. Clear? Plus sign. Its differentiation. Cos pi x by 2a into cos pi x by 2a into differentiation of sine, that is cos pi x by 2a into pi by 2a. So this we get. So here we see that limit x tending to a, pi by 2a is common, so 2a by pi. Just we can write here minus minus plus. Just now minus plus sine square 1 upon sine square pi x by 2a plus minus cos square pi x by 2a. Just we get this. Now x tending to a, that means a sin 91. So this is 1, this is 0. So answer is what? 2a by pi into 1. 2a by pi into 1. Okay. So just answer is 2a by pi. So this is answer. Clear? 2a by pi. So this is the technique for finding the value of indeterminate form 0 into infinitive. Just write in the form of infinitive by infinitive and then try to solve, and then also you can convert it in the 0 by 0 format and use L hospital rule, and then you can get the limit. Okay. Now take from another form, indeterminate form, just like 0 power 0 form, and 0 power 0 form can be used. Now here infinitive minus infinitive form also can be used. Another form is what? Infinitive minus infinitive form. So limit x tending to what? X tending to 0, 1 by x square minus quarter square x. 1 by x square minus cot square x. This format. Okay, just try to solve it. Here, see how can we solve? Here, main thing is what? If function is given and format is this, infinitive minus infinitive form, then just do it together. Limit x tending to 0. What? First of all, if either 10x or cos x, then you can convert it as a fraction, cos by sin, sin by cos. So here we can write cos square x by sin square x. Just do it. X tending to 0. And then we can write x square sin square x, just taking LCM. Okay. Here sin square x minus x square cos square x. X tending to 0. That is 0 by 0 form also. What is form? 0 by 0 form. Okay. 0 by 0 form. For solving this, just whenever we see that here 10x or sin x, so we can convert it in 10x by x or sin x by x, limit is 1. So here we can write like this: sin square x minus x square cos square x upon x power 4 x square upon sin square x. Just we can write like this. Here sin x square x by sin square x means what? X by sin x square. Its limit is tending to 1. So square limit also tending to 1. So here we can write x tending to 0. So we can write limit x tending to 0 sin square x minus x square cos square x upon x power 4. Since limit x tending to 0 x by sin x is equals to what? 1. Just generally just write like this formula: sin x by x. Since this sin x by x tending to 0 equals to 1. So here also we can set off like this here. How? Limit x tending to 0 in first term sin square. So sin square x upon x square into 1 by x square minus x square cot. This is cot. No, cos, sorry, cos. Okay. Cos square x. We can write like this: sin square by x to the power 4. So x square is here, x square is here. So sin square, sin x by x, limit 1. So this can be also written as what? Limit x tending to 0, 1 by x square minus x square cos square x. Just it can be also written like here x to the power 4. So just by x to the power 2 by x to the power 2. So this is value. X tending to 0, infinity minus infinity form also. Infinity minus infinity form. So it can be also converted. What form is this? Infinity minus infinity form. Okay? Infinity minus infinity form. So again, just do it. Collect it and use same method for solving. Okay? Just see, after this line here, limit x tending to 0, x square 1 minus cos square x upon x square, 0 by 0 form. x tending to 0, 0, 0, 1, 1 minus 1, 0, 0 by 0 form. So use L Hospital rule. Limit x tending to 0, 0 minus 2 cos x minus sin x upon 2x. Clear? So it can be solved easily. 2 cancel, minus minus plus. So limit x tending to 0 cos x, limit x tending to 0 sin x by x. So what is the limit of this? Just 1. You can write the value of this is equals to what? 1 into 1 equals to 1. So this is answer. Okay. Of which format this is? Infinity minus infinity form. Now next form. What is next form? Next form is 0 to the power 0 and 1 to the power infinity, infinity to the power 0. Okay, so take from this form questions as 10. Okay, so here just see cos x pi by 2 minus x, limit x tending to pi by 2 cos x power pi by 2 minus x, 0 in power 0 form, 0 power 0 form. Okay, we know the 0 power 0 form or infinity power 0 form or 1 power infinity form, all can be done by using logarithmic. Just put, so let us suppose the limit is y, then log y, find the value of this limit, and then y equals to e to the power that limit is equals to, you can find the value. Okay, so here 0 to power 0 format is this, pi by 2 minus x, this. Clear? So let us suppose that 0 to the power 0 form is this, because cos 90 is 0, pi by 2 minus x 0, so 0 to the power 0 form. So let y equals to limit, just suppose y equals to that limit, then x tending to pi by 2 cos x or pi by 2 minus x implies taking logarithmic on both sides, taking logarithmic. So log y is equals to what? Log limit of x tending to pi by 2 log of cos x power pi by 2 minus x. Just use the rule of logarithm. What? Limit x tending to pi by 2 minus x log of cos x. Okay, so here we see that x tending to pi by 2 0 into cos 90 is 0, log 0 infinity, 0 into infinity form. What form? 0 into infinity form. So it is which form? 0 into infinity form, and it can be solved by using what rule? Just convert it in terms of infinity by infinity form or 0 by 0 form. So here just we convert it as infinity by infinity form. So this is equals to what? Limit x tending to pi by 2 log of cos x. Generally first time for this form we write in infinity by infinity form, then 0 by 0 form. So here 1 upon pi by 2 minus x, just we can write like this. Okay, now this is 0, this is infinity also. So infinity by infinity form. So it is what? Infinity by infinity form. Now infinity form. So apply rule. Apply what? Apply L'Hospital rule. L'Hospital rule. L'Hospital's rule. Okay. L'Hospital rules. So just differentiate it. So limit x tending to pi by 2, here minus 1 upon pi by 2 minus x square into minus 1. Okay, minus x just like this, minus 1 upon pi by 2 minus x square and minus 1. Differentiation, and its differentiation cos x by sin x. So minus sin x by cos x. Minus sin x by cos x. Because 1 by cos x and minus sin x. So this is the value. Now here we see that x tending to pi by 2. There is cos 90. Cos 90 is 0. This is 0. This is 0. So just we can see here also infinitive. This is infinitive. Infinitive by infinitive form again. So just we have to write it in terms of 0 by 0 form. So for that we can write it. What is the value of this? Log y. So we can write this of in which form? Again, this in which form? Infinity by infinity form. So it can be written like this. This minus minus plus this tending to pi by 2 minus x square upon what? 10x. Upon what? 10x. So just sorry, cot x. Now here see that limit also x tending to pi by 2. 10, 90 infinity. Cot 90 is 0. This is 0. This is also 0. So 0 by 0 form. 0 by 0 form. Because we are converting in which form? After infinity by infinity form, 0 by 0 form. So just this 0 by 0 form. Differentiate it. Again apply rule. X tending to pi by 2. Here 2 pi by 2 minus x into minus 1 upon cot cosec square x. Cosec square x. Okay, cosec square x. So this. Again applying rule. Again apply rule. Okay, rule means L'Hospital rule. Then now we can get here limit x tending to 0. Pi by 2. X tending to pi by 2. But here we see that minus 2 pi by 2. So I think this limit is 0 because like this pi by 2 minus x into sin square x. So it can be solved 0. Okay, so what we get? Log y equals to 0. So this implies y equals to what? E to the power 0 equals to 1. So y equals to e to the power 1. That is y equals to 1. Answer. Okay. Y equal to e to the power 0, 1. So y equals to e to the power 0 equals to 1. That is limit is 1. So similarly we can solve infinity power 0 form by using logarithmic. And so 1 power infinity form by using logarithmic. Power involved, so just we can solve it by using logarithmic. Okay, so just see one more question here. So that is, just take x tending to 1 2 minus x, limit x tending to 1 2 minus x, powers 10 pi x by 2, 10 pi x by 2. This is 1 power infinity form. 1 power infinity form. So just for this form also we use logarithmic. Okay, so let y equals to limit of x tending to 1 2 minus x power 10 pi x by 2. Pi x by 2, yes. Now, implies logarithmics, just take log on both sides. So limit x tending to 1 log of 2 minus x power 10 pi x minus 2 implies what? Log y equals to limit x tending to 1 10 pi x by 2 into log of 2 minus x. So which format is this? This is x tending to 1 10 pi by 2. X tending to 1 10 pi by 2 means infinitive. This is 2 minus 1 log 1 0. So 0 into infinity form. Which form is this? 0 into infinity form. 0 into infinity form. Just we get. Now we will convert it first infinity by infinity form and then 0 by 0 form. So here x tending to 1. This infinitive, this is what? 0. So this is infinitive. So log 2 minus x upon 10. So we can write quat pi x by 2. Just like quat pi x by 2. So quat 90, 0. This is 0. So 0 by 0 form here. Just we can convert 0 by 0 form direct. Now apply L'Hospital rule. So limit x tending to 1. So log 2 by, so 1 upon 2 minus x into minus 1. This is denominator, differentiation of numerator, and denominator differentiation. What? Cosec square x pi x by 2 into pi by 2. Clear? Quat x equals to minus also differentiation of quat x equal to cos minus cos square x. Now here we see that x tending to 1 cosec 90 sin 90 1, so cosec 90 also 1. So this is 1. If this is 1 and this is also 1, so we can calculate the value. So here what? Minus minus plus 1 by 2 to 1 upon pi by 2. So 2 by pi is the value is this what? 2 by pi. Because cosec 90 Sin 91, cosec 91. This is 1. Minus minus plus. 2 minus 1, 1. 1 by 1. This is 1 by pi by 2, 2 by pi. So this we will get log y equals to this. So from here we see that y equals to e to the power 2 by pi. So this is our answer, e to the power 2 by pi. So final answer is what? E to the power 2 by pi. So this is e to the power 2 by pi. This is our answer. Because we require the value of y that is limit. So this. So power format can be evaluated by using logarithmic. Okay. So now I will give some questions for your practice. Just do it. All these questions in your copy. Okay. So one by one, just I am writing here questions. You note down all the questions and solve in your copy. Use any of the method for converting, either 0 by 0 form, infinity by infinity form, 0 into infinity form, infinity minus infinity form, 0 power 0 form, infinity power 0 form, and also one power infinity form. Okay. So first question is, find the value of the a and b such so that, first question, find the value of a and b so that limit x tending to 0, so that limit x tending to 0, x a plus b cos x, x a plus b cos x minus c sin x by minus c sin x by x to the power 5 equals to 1. X to the power 5 equals to 1. X to the power 5. A, B and C. So that limit this is equals to 1. Okay. Second question. Evaluate limit of x tending to 0 a power x, b power x, c power x upon 3 power 1 by x. Power 1 by x. Clear? Second question. This is second question for your solving. Now, and another questions from just third. Evaluate limit x tending to 0 e to the power x minus e to the power minus x minus 2x ten x minus x 10x minus x. Okay. Question 4. if question 4, if limit x tending to 0 sin 2x plus a sin x, sin 2x plus a sin x, sin 2x plus a sin x upon x cube be finite, then find the value of a find the value of a and also find limit. Okay, question 4. Now question 5. Evaluate limit x tending to 0 1 by x minus cot x. Okay. Six, limit x tending to 0 cot x minus 1 by x upon x. Okay. 7, cot x for sin x. Limit x tending to 0 cot x for sin x. Cot x for sin x. This is infinitive or 0 form. Just use logarithmic. And limit x tending to 0, not 0, pi by 2. Pi by 2. Cos x for sin x. Just evaluate these two both. Okay. Then limit x tending to 0 tan x by x power tan x by x tending to power 1 by x square. That is what? Limit x tending to 0 tan x by x 1. 1 power 1 by x 0 1 by infinity 1 power infinity. 1 power infinity form 0 power 0 infinity 0 form. This is infinity power 0. Okay. So just solve these three. Find these three. Limit 7. Now 8. Evaluate limit 1 plus log x minus x 1 plus log x minus x upon 1 minus 2x plus x square. Clear? This question 9. limit x tending to 1 log 1 minus x cot pi x by 2. Okay, 9. And then just ten evaluate limit x tending to 1 x by 1 x minus 1 x by x minus 1 minus 1 upon log x minus 1 upon log x, and 11 evaluate limit x tending to 0 x plus sin x plus sin x plus sin x plus sin x for 10x x plus sin x for 10x. Okay, and 12 limit x tending to infinitive e to the power x plus x power 1 by x e to the power x plus x power 1 by x. 13 10 pi x by 4 power limit x tending to 1 10 pi x by 4 power 10 pi x by 2 10 pi x by 4 power 10 pi x by 2 10 pi x by 4 power 10 pi x by 2. This and 14 question, last question. Okay, 14 hyperbolic sin x by x limit x tending to 0 hyperbolic sin x upon x power hyperbolic sin x upon x power 1 by x square. Okay, so do all these questions by using technique just we have discussed in this class. Okay, and do all the questions, also all the solved questions and this practice questions in your copy. Okay, and write very neatly and solve all questions in your copy. Okay.